These are the notes for section 7.3. This was what was taught in class for this particular section, and the goal for this particular lesson, as you can see in my objectives, is I want you to, after seeing this lesson, I want you to be able to add and subtract radical expressions. Okay? And then the second half of the lesson will focus on how do we multiply and divide binomial radical expressions. So just remember the word binomial literally means bi means two and nomial means terms. So we should be very familiar with that term, binomial. And radical means that of these two terms, at least one of the terms will be in radical form. Could be both, but at least one of them will be radical. Okay, and so we're going to take a look at how these binomials are multiplied and divided. Okay, well, let's start with addition and subtraction. This is pretty easy, pretty straightforward. There are two things that must be true of radicals before they can be either added or subtracted. And I have this for you in red. The first thing that you should check for is, do the radicals have the same root? Or we use the word index. Is the index the same in this case, both cases? So these are both square roots. So remember, there's an invisible 2 in this little gap here. So this is possible. And when I add radicals together, I'm really only adding the numbers in front of the radical. So 7 plus 3 is 10. And we're going to show that times the square root of x, y. So very similar to what you're used to seeing when you first learned about like terms. These are called like radicals. For example, like terms 5y plus 7y. Back in Algebra 1, you learned that that would just be 12y. You only worked with, you did the operation on the coefficients, and the y, the variable, just remained as part of your answer. And so adding and subtracting radicals is really the same idea. Okay, look at letter B. This is not possible because the number underneath the radical, which we call the radicand, is not the same. Therefore, if this were a homework problem, you would put something like not possible, or you can just write NP. Cannot be combined as a single term using subtraction. For letter C, I just wanted you to make you aware of this because some people forget. Just like variables that are written, like the variable x, you learned in Algebra 1 that there is an invisible coefficient of 1 in front of that variable. And that's also true for radicals. In this case, the square root of 7, you can think of it as having an invisible 1 in front of it. So now I'm going to be subtracting because they have the same root and they have the same radicand. So my answer will be 1 minus 6, which is negative 5, times the square root of 7. So those are some examples of how you add and subtract radicals and when it's possible to do those operations. And that's pretty much what you're going to be doing on this first block of problems in your homework. Okay, well, the next block of problems, you're still adding and subtracting, but these get a little bit more involved because we have radicals that at first glance look like these cannot be combined because they don't have the same radicand. They don't have the same numbers underneath the radical. So you might think, well, these are not like radicals, so there's nothing we can do. Well, hold on a minute, because before we make that decision, we need to make sure that these radicals are simplified. Okay, so this is kind of a review of past lessons. The way we would simplify the square root of 20 is I would use the perfect square root radical factor 4, square root of 4, times the square root of 5, which is not perfect, cannot be simplified. Okay, And notice I still have this 3 being multiplied, and we'll come back in just a minute and take this another step. The square root of 45 using radical factors, that would be the square root of 9, which has a perfect square root, times the square root of 5, which does not. And for this last term, notice I brought down the 4, and for the square root of 80, I'm going to use the perfect square root 16, square root of 16, and multiply that times the square root of 5, which does not have a perfect square root, but these multiplied together equal the square root of 80. Okay, so let's just take it one more step so I can make sure everybody follows what's going on here. This would simplify as 2 square root of 5 and 3 square root of 5. And in the parentheses here, we would have 4 square root of 5. All right. Notice, now that I've simplified this square root of 4, I have the regular or non-radical number 2 that can be multiplied times this other non-radical number 3. So this is actually going to become 6 square root of 5 minus, this doesn't change. Obviously, I didn't have anything to multiply by 3 root 5. But here, the same thing, it's very similar to what we did on the first term. I have this non-radical 4 times the other non-radical 4, making 16 root 5. Now I have like radicals, and so I just go left to right and operate with the numbers in front of the radical. 6 minus 3 is 3. 3 plus 16 is 19 times the square root of 5, which ends up being my final answer. Okay, similar problem with number 3. So we want to work on simplifying. Now these are cube roots. As they are right now, they're not like radicals, but after we simplify, let's see what we come up with. So once again, I'm going to show the cube root of 81. 81 itself does not have a perfect cube root, but there is a perfect cube root number, 27, that does divide into 81 evenly. So we could rewrite the cube root of 81 as the cube root of 27 times the cube root of 3. All right, and then over here in a similar way, 54 does not have a perfect cube root, but once again, 27 divides into 54, so we could rewrite the cube root of 54 as the cube root of 27 times the cube root of 2. Okay, simplifying the cube root of 27, that's 3. Now remember what we did up here. This 3 can be multiplied times this other 3. They're both non-radical now. 3 times 3 is 9 times this radical, cube root of 3. And then once again, the cube root of 27 is 3. 3 times 2 is 6 times the cube root of 2. Okay, well, we've simplified, but we've gone as far as we can go. We can't actually combine these using subtraction because they don't have the same radicand. So this ends up being my final simplified answer. So I have a few people that have answered this in the past, not possible. Well, that's true. It's not possible to combine these, but the directions just said to simplify, and we have done that. So just because you can't come down to a single number radical answer doesn't mean you haven't simplified. So the correct way to answer this question would be just to show these two different radicals being subtracted, but we are unable to put them together as one single term. Okay, so that finishes off number 3. All right, so we're moving now into the second objective, which we mentioned earlier in this lesson. We want you to be able to multiply binomial radical expressions, and that's what we have here. We have binomials in each case, and in each binomial we have a radical. So how do these multiply together? Well, anytime we multiply binomials together, we are going to use the FOIL method. So that should be familiar to us. Starting with the first terms multiplied together, 2 times 1 is 2. If you multiply the outside terms together. 2 times negative 5 root 3 is negative 10 root 3. Now go to the inside terms, multiply together. 4 root 3 times 1 is just positive 4 root 3. And then when we get to these last terms, I want to slow down just a minute. And how do we handle multiplying these expressions that are both regular number times a radical? This tends to give people a little bit of trouble. So I'm going to show over here how we get this last term, and then hopefully working this out will help you. When you multiply these, I call them their combination non-radical times radical, these terms when they're multiplied together. You really have to break them up into parts, okay? Start by multiplying the numbers that are not under the radical. 4 times negative 5, that's negative 20. Then multiply the radicals together. The square root of 3 times the square root of 3 is just 3. Now you're going to multiply these two results together. So this last term that we would get, multiplying these two last terms together, would be negative 60 or minus 60. Okay, so just once again, multiplying these expressions that are a regular number times a radical. Just think about multiplying the numbers that are not radical together, then multiplying the radicals together, and then multiplying those two products together. Okay, and now all that's left to finish my answer here for number 4 is to combine like terms. So I have the numbers 2 minus 60, which is negative 58. Those are like terms. And then I've got like radicals. Negative 10 plus 4 is negative 6 square root of 3. And that ends up being my final answer to this problem, because obviously I don't have like radicals. These are not like terms. And this does show the preferred way of writing binomials that have part regular non-radical number and part radical number. It's preferred that you write the radical part last. Otherwise, there may be cases where this is not related to this problem. I'm just going to give you another example. If I write the radical part first and then follow that with the regular number part, there might be a little confusion here. This is a binomial, but as it's written, sometimes it's not quite understood whether or not this negative 3 goes under the radical. Does it stay outside the radical? So if we write the radical last, it helps us to avoid that possible confusion. So there's really it's more of a practical reason than anything else. So if you'll just keep that in mind. Okay, now number 5, these are binomials, but they're special because if you notice, in each case we have the same terms. They're identical with one exception. They have different signs. Identical terms, but the signs are different within each binomial, or comparing the two binomials. And we have a special term for this. These are called conjugates. Okay, so conjugates are binomials that if you compare them, the terms are exactly the same, but the signs are different. So the way we multiply conjugates, it's a little faster because we don't have to go through all 4 parts of FOIL. If you did, it wouldn't be terrible, because what you'll find is these two results of doing the outer and the inner parts, going through the FOIL process, these terms will always cancel each other when you're multiplying conjugates. So if you recognize that your binomials represent conjugates, then you can really just multiply the first terms together, 5 times 5, and then multiply the last terms together, and square root of 11 times the square root of 11 is just 11. And it's subtraction because we're multiplying a negative times a positive, which makes negative. And so multiplying conjugates are really pretty easy. You can just eliminate. Now this is just for conjugates. Notice up here, I do not have conjugates. I had to go through all 4 parts of FOIL and then combine like terms. But if you recognize you're dealing with conjugates, then you can just skip over the outer and the inner parts of FOIL and then combine the numbers that result. Okay, we need to know about conjugates in order to help us with problems like this, and this is the last set of problems in your assignment. The directions tell us to rationalize the denominator, and we learned in the previous lesson that rationalizing a denominator really in everyday language just means get rid of the radical in the denominator. Well, this is a little different because before we just had a monomial expression that we had to rationalize. Well, this is a binomial, okay, this binomial radical expression. So we have a different way of rationalizing denominators, radical denominators that are binomial, 2 terms. And it goes back to that term that we learned on the previous slide. We're going to use the conjugate of the denominator. Well, remember, conjugate just means we have exactly the same terms, but we're going to use the opposite sign. So the conjugate of 4 plus the square root of 3 is 4 minus the square root of 3. And just keep in mind, when you multiply by this fraction, it should always equal 1. So just look at the denominator, determine what the conjugate of the denominator is when this is a binomial, and multiply by that on the top and the bottom. All right? So what's going to happen now is in the numerator, just like we did in this problem, we are going to have to use FOIL for the numerator. So let's go through that. 2 times 4 is 8. 2 times negative square root of 3 is negative 2 times the square root of 3. Negative root 3, remember there's an invisible 1 in front of these, so negative root 3 times 4 is negative 4 root 3. And then when you come to the last, these are a little bit easier because it's just a radical times itself. Notice it's negative times negative, which makes positive, and the square root of 3 times the square root of 3 is just 3. Okay, and we'll come back and simplify combining like terms in just a minute. Let's go ahead and work on the denominator. These are conjugates, so all we really need to do is multiply the first terms together, 4 times 4, minus the last terms together. Root 3 times root 3 is just 3. And now we'll simplify like terms, or combine like terms, and see if we can cancel anything. And if not, then we will be finished. So let's start with 8 plus 3, which is 11. And then the radicals, negative 2 minus 4 is negative 6, root 3. And then the denominator, 16 minus 3 is 13. There isn't anything I can do. I mean, I would typically look at these numbers that are not under the radical to see if I could reduce this fraction. So besides 1, which really doesn't count because that wouldn't change anything, there are no numbers that would divide into 11, 6, and 13. So therefore, I can't reduce this fraction anymore. And so this ends up being my final answer to this problem. And you've got these problems in this block look very much like this. Okay, so you know the assignment. This is what we will be checking from section 7.3. So if there's anything you can do to help you, either send me an email or bring your questions to class.